Okay, so let's get started. This is what we are going to do today. First of all, I have done a grouping you guys into groups. And so check your group via ITC LMS. So I don't want to put the direct URL in this public homepage everybody can see. So just get the URL from ITC LMS. And this is what it actually looks like. So basically, like I said, each group has one person working on a particular programming language, except for some groups that have only 3 people. And one thing is that, so I asked where you want to work, either classroom or either home or either way. So for those who said you can work either at home or classroom, I assume that no, I group them with people who like to do it in the classroom. So I would generally expect larger people to come in the classroom from the next weeks. So we are not going to do the group work for today because the announcement was just made before just yesterday. So I thought it's too early to get started with the group work. So the important announcement for those who say you can work either home or classroom. So please come from the next week. Yeah, and so mostly I assign a language that each of you prefers most, but like I said, it's not completely possible. So there are a few of you who didn't assign to the language you preferred most. So I apologize for those of you who assigned to a language that you didn't prefer, or especially Suzuki-kun, so who gets assigned to the language that you didn't like most. So you like least. Sorry about that. Okay, so this is the grouping. Any question about this? So from the next week, we're gonna do group work. So Zoom folks will be put in the Zoom breakout rooms, but most of you just come here and sit together to do a group work. And actually, this room may be a little bit too small if all of you who said either come from the next week. But what I'm hoping is that actually the next room over there is almost empty. And there's another room that is completely free. So if we can ask those who are working in the other room can move to the other free room, then we can actually use both 2 rooms. So this is what I'm planning to do for group work. Okay, so this is grouping. So any question about this? Let me check the Zoom chat. Okay. So for today, I'm going to spend the first 30 minutes or so reviewing what you have done the last week and summarize how do these 3 languages guarantee type safety, which is important. So the last week, the last week's assignment was actually about something called subtyping polymorphism. So I'm gonna summarize what each language does about this. And today's new topic is something called the parametric polymorphism. So I'm gonna spend 15 minutes or so explaining what it is about. And then you're gonna work on another notebook, which is about this new topic, parametric polymorphism. And like the last week, so you are going to start writing and sharing your answers in the spreadsheet. So this is what you have been doing in the last 2 weeks. Okay, so let me get started with this one. I guess I forgot to push the latest version in the home page. So let me do it now. Oops. Okay, I think if you click on this this link now, I guess you get the latest version. Okay, yeah, I think this is the latest version. Okay, so before getting into the slides, so let me quickly review what you have shared in the spreadsheet. So the answers to the last week's assignment or exercise. Okay, so it was about something called subtype polymorphism. So subtype polymorphism is about how to have a single variable of a certain type that may hold values of different types at one time. So the particular example was the static type is shape, so generic shape, right? But there may be many different kinds of shapes like ellipses and rectangles. And at runtime, we like to have this single variable of type shape to hold a value of rectangle at one point and a value of ellipses in the other point. So this is what polymorphism is about, right? And so how to make that happen in the particular language you worked on, right? So this is a quick review of Go. So this is a Go language. So you define these two types, rectangulars and ellipses, just in an ordinary way. But we like to have a notion of shape that encompasses both two types. So how to make that happen in Go? Well, actually, so you don't have to do anything in particular to connect. Okay, so rectangular is a kind of shape and ellipse is another kind of shape. So you just implement, for example, common method called area for rectangle and ellipses in pretty much ordinary way. So there's nothing very explicit about, okay, so I like to make rectangular a kind of shape and ellipse is another kind of shape. And you just define something called interface that captures the property that, okay, so when a type, so if you wanna call some type to be a kind of shape, then you have to implement this area method that returns float 32 or whatever. Then it pretty much automatically happens that if you, for example, put rectangular and ellipses in a single array and say, okay, so I like to have an array of shape, then Go pretty much automatically infers that both rectangular and ellipses sort of conform to this interface, which says you have to have an area method that returns float 32. But so the Go language automatically checks if this is the case, right? But obviously, if you write something like this, so Go language is able to automatically check if this is indeed the case. So this is Go. So one thing that is noteworthy is that you don't have to say anything explicit about the relationship between shape and rectangular, or shape and ellipsis, not to mention the relationship between rectangular and ellipsis. So automatically inferred by the Go language. It is something called the structural subtyping. The fact that rectangular and ellipsis conform to what the interface shape says is automatically inferred by the compiler. And then you can write a method that scans an array of shape. So for each element in the array, you simply call area method. And so this variable shape holds a value of rectangular at one point, so in one iteration, and the value of ellipsis in another iteration. So this is polymorphism. And so what about Julia? Julia, actually everything is very straightforward, but the one particular thing about Julia is it actually does not guarantee type safety. So the type error may happen at runtime. So it is very straightforward to put, for example, both rect and ellipsis in Julia. But this is not because Julia has a mechanism similar to Go, so something like interface or some other things. So it is simply happening because Julia doesn't care about the types of arrays during the compile time or the before execution, to be more precise. And when you write a method that is something like this, well, it's again very straightforward. You don't have to anything tricky to allow a function like this. But it's not that you are guaranteed to. So it's not guaranteed that all elements of this array have an area method. So you could actually make an array whose element may not have this area method. So when this happens, the error happens at runtime. So this is very different from the other three languages you are working on. Well, things are as straightforward as Python, but like Python, it's not type safe. So let me come back to OCaml after Rust. So Rust is somewhat similar to Go. So again, so in the beginning, things are pretty much ordinary, right? So you just define rect and ellipsis in whatever way you want. And so things start to become a little bit tricky when you like to have an array that has both rectangular and ellipses. So like Go, you have to explicitly define something like an interface, but in Rust it is called trait. So trait is just like an interface in Go, which essentially specifies what kind of method each type needs to define if the type wants to be a kind of shape, right? The kind of trait. So this basically says, okay, so if you want to make a type to be a kind of shape, then the type has to implement this area method that returns F32. And this is exactly what you are doing in the following, right? So, but somewhat unlike Go language, in Rust, you have to explicitly say Okay, so I'm going to implement this shape trait for rectangle. So I'm going to define a method that is attached to rectangle, just so that rectangle is considered to be a kind of shape. So you have to make these things explicit in Rust. But the other things are pretty much similar to Go language. But with that setting, you can, for example, have rectangle and ellipses and put both into the same array. So vector in the case of Rust. So you need to actually do something else. So you cannot actually simply say, I want to have a vector of shape. So you instead have to say, okay, so this stands for dynamic. But I don't want to get into it for today. But you have to say, okay, so this shape may hold a value of different types at runtime. So you have to make that explicit too. But otherwise, this is conceptually similar to what you did in Go. Okay, so this is what Rust looks like. Finally, OCaml. OCaml is, well, so it's actually very interesting. So in OCaml, generally speaking, everything tends to be very automatic. You don't have to say many things explicitly. So I wanna make this class to be a kind of another interface or whatever. So actually, the OCaml doesn't have a notion of interface or trait or anything similar. So you just have ordinary classes and ordinary types. So before getting into these types things, so one thing that is actually very worth noting in OCaml is that, okay, so this is definition. So valid definition of a rectangular class that has an area method like this. So, but actually one thing that is worthy of noting is that you do not have to have any of these, any of these 4 lines. You simply refer to Excel and YL that you received as an argument to the constructor. So you don't have to explicitly store them as a part of objects, instance variables, so-called instance variables. So actually, OCaml definition can be as concise as this. So this is actually a very interesting part of OCaml syntax. But of course, you could do this in this way. So it's just unnecessary and somewhat redundant. The main point being here, the main point here is that, okay, so just like Go or Julia and Python, you simply define rectangular and ellipses. And both happen to have area method. And both happen to return a floating point number. So from the OCaml perspective, the interface or the type definition of rectangular and ellipses look almost identical. And this is what OCaml automatically reasons about. And one thing that is interesting in OCaml is that you don't have to do anything particular to put rectangular and ellipses in one single list. This is because OCaml reasons by looking at the definition of rectangular and ellipses, the OCaml reasons that these 2 types are actually identical. So both have method called area, and both returns a floating point numbers. So if, for example, one of the definition, either rectangular and ellipses look somewhat different. For example, when you have an extra method, another method, let's say perimeter. So let's say rectangular has a perimeter, but ellipse doesn't. Then you cannot do something like this. So like this, so OCaml actually reasons about the what's so-called compatibility or identity between two types pretty much automatically. So this is a very interesting part of OCaml. So this is what I actually wrote for the purpose of demonstrating it. So this rectangular, well, so I added another method called perimeter to the rectangular. And ellipse doesn't have this same method, perimeter. So these two types become different, right? And then you cannot simply write something like this. So it used to work before, right? So before you have this perimeter method, then this automatically compiles, right? So let's just comment it out. Then does it complain? So I think it's complaining about something else. So line 4. I'm sorry, let me fix the size of the window. Would I do too many arguments? Okay, so this is one. Okay, so it's still complaining about the unused variable, but it's just a warning. So this is what I say. So simply because rectangular and ellipses happen to have identical interface, both have area method that returns floating point number, and that's it. Then yeah, automatically, so OCaml automatically infers, okay, it's okay to have both rectangular and ellipses in the same list. But this is no longer the case if you have another method in rectangular. So it starts complaining about so line 5. Why is that line 5? Why I believe it's complaining about here. Okay, so yeah, I believe that this error is complaining about this line, right? So the first element was rectangular, but the second element was ellipse, and these are now different, right? So the OCaml expect the second element to be of the same type with the first element, which was not the case. So that's why it's complaining. And the way to get out of this is to make rect look like ellipses explicitly. So this is where you have to do something explicit to make these two things in a way compatible. So this is the way you do it in OCaml. So this is rectangular, which happens to have a perimeter method, but for the purpose of making it compatible with other things, which is ellipses that has only area method, you explicitly say, okay, so even though this is rectangular, I want to consider it to be ordinary shape. So you can in fact say ellipse ellipse here, but well, it's not very comfortable to say rectangular is a kind of ellipse. So I explicitly define a type called shape, which explicitly say, okay, shape has any object that has an area method and that returns a floating point number. And this is a operator in OCaml that explicitly consider a value of some other type to be a value of different type, shape in this case. So OCaml reasons that this is valid. So new rectangular has, or at least has an area method. So forget about something else like perimeter. And you simply consider a rectangular object to be of type shape. So you can make this explicit and this program compiles. Of course, you cannot do anything specific to rectangular, like applying perimeter method for elements in these shapes anymore. So shapes is, well, actually a list of shape whose element is only guaranteed to have an area method, not necessarily a perimeter method. But in this way, you can simply mix objects of different types into a single list. So this is how you can make that happen in OCaml. Any questions so far? Okay, so let me summarize what you have learned in somewhat high-level terms, so not specifically to a particular programming language. So given these flexibilities, so to speak, so how or if they guarantee type safety. So slides that follow briefly explain how it happens in Go, Rust, and OCaml. So like I said, Julia doesn't guarantee type safety. So runtime type error may happen. So here type safety means that, well, vaguely speaking, it says that there's no possibility that no such method error happened during the runtime. So if you write a program that may result in no such method error, then it will get caught before execution. This is what type safety means in this context. So somewhat more specifically, when a program containing an expression like this, so O.M, so you are trying to apply a method M on this expression O, then so if this passes a static type check, so type check before execution, O always has method M at runtime. So in any code path the program may exercise. Okay, so and again recall that this is not the case for many languages, including Python, Julia, C++. So this is a common framework in which you reason about something like this, whether the particular language is type safe. Well, so how to make the language type safe, despite there is a polymorphism. So generally speaking, so static type checker, so type checker before the execution likes to guarantee that for any expression E appearing in the program whose static type is S, any value E could take at runtime. So any value E could be evaluated to at runtime. can be safely put in anywhere S is expected. So this is what we like to guarantee, right? And so more intuitively, in more intuitive, simpler terms, it basically says any such value that E could be evaluated to implements all the methods it specifies. Right. So why this is what we like to generally guarantee. So in compile time, or more precisely before execution, basically the static type checker generally looks at every expression that appears in the program, right? And for any expression E that appears in the program, the static type checker knows its static type, right? The compiler does not necessarily know all the runtime types it may have, right? But it only knows its static type. And when you, the compiler or the static type checker sees, for example, an expression like O.M, something like this. Well, generally speaking, E, so any expression .M, then the compiler judges if this expression is valid or not by looking at the static type of O and whether this static type specifies the method M, right? So generally what the static type checker does is, so when it sees something, so some expression like this, so it first checks its static type and checks if the static type has a method M. So this is how the static type checker checks if this expression is valid, right? So in this setting, what we like to guarantee is that, so again, even if the static type is known to be S, it does not necessarily mean all the values that E could take at runtime is exactly S. So for example, S may be a shape, but at runtime, the value E may take is something else like rectangular or ellipses, right? So generally speaking, so any value E could take at runtime can be safely put in anywhere S is expected. If this is the case, it looks okay to accept this program, right? So to that end, so one thing we at least have to guarantee is that for any assignment-like operations, so I get to what is exactly assignment-like operations later, but for now, let's just consider it to be ordinary assignment, like O equal P. So assigning P to a variable O. So you have to guarantee that any value P could take at runtime can be safely put in anywhere S is expected. So sorry, S is the static type of O. So basically, when a value from so one place to another, and left-hand side and right-hand side may have slightly different types. So in order for this to be allowed, we generally like to guarantee that any value P could take at runtime is something that can be safely put in anywhere S is expected. So this is exactly what we have been doing. So for example, O is a variable whose static type is shape, right? So intuitively speaking, we think it's okay to assign rectangular or ellipses to a variable of type shape, right? So this is what this statement is trying to capture. So in more general terms, well, it's approximately saying that any value P could take at runtime implements all the methods S specifies. So this is a common framework in which you reason about the type safety of the particular programming language. And we like to check this property. We like to check if this property is going to hold or not by comparing P's static type, let's say T, and O's static type, let's call it S. So this is what boils down to the relationship between two types. So P's type is T and O's type is S. Then what kind of relationship must hold between these two types? Well, it basically says that any value the type T could take can be safely put in anywhere S is expected. So this is what we like to capture. And this is precisely what we like to capture by subtype relationship. So the relationship that is written as T smaller than S. So this is the common framework. So basically, when you have an assignment or assignment-like operator, okay, so this is a short note about the assignment-like operations. So assignment-like operations is any operation in which a value is stored to a location of potentially different static type. So the ordinary assignment is exactly an example of assignment-like operation. But well, another assignment-like operation is assignment into structure element or an array element. And another instance is function calls, so passing values to parameters, right? So basically, you are passing a value and storing it to whatever parameter name of the called function, right? So this is another assignment-like operations. So for all of these assignment-like operations, we basically like to guarantee that right-hand side, so the static type of the right-hand side is a subtype of left-hand side. So this is the common framework. And let me say again what the subtype relationship is mean to capture. So when you say T is a subtype of S or written T smaller than S, any value of T can be safely put anywhere S is expected. And this is not exactly equivalent to saying T has all methods S has, but there's something subtle, so something more about this. But for now, let's say, so this property is, well, basically equivalent or almost equivalent to saying T has all methods S has. So this is basically what a subtyping relationship is trying to capture. But the exact details somewhat depend on each language. So in the next 10 minutes or so, let me go over each of these languages, hopefully very quickly. So actually, so let's first talk about Go. So details are actually on this assignability section of Go reference. So if you wanna look at the details, just go to this website. But the question all these programming languages have to answer is, so when is a type T a subtype of another type S, T smaller than S? So when exactly this is the case in the case of Go? So basically, well, so there are some other cases. So you can look at more details. So you can look at this page for more details. But basically, this is this is the case either when S and T are completely the same type, well, which is obvious. But the other more important case is that S is an interface and T is a structure or another interface that implements whatever that means, but that implements S or a pointer to a structure or interface that implements S. And then the remaining question is, when is type T say to implement an interface S? And this is what Go manual, well, actually, it doesn't precisely define when this is exactly the case, but well, just by playing with some trivial programs and playing with compilers, it appears that this is the case when, well, first of all, T has all the methods specified in S, which is obvious. So when S says, okay, this interface needs to define method X and Y, but T doesn't implement either X or Y, then, well, it doesn't, it is not say to implement an interface. And the other condition is each method in T that is specified in S has exactly the same type as the corresponding method in S. So it looks somewhat obvious, but this actually doesn't have to be the case. But well, as far as I can tell, by playing with the Go compiler, well, this is the condition Go compiler is trying to check. So if S says, for example, this interface needs to have a method called M that returns floating point number, then any type that claims to implement S needs to have the method M that returns exactly floating point number. It cannot be something else. So this is Go. And what about Rust? So Rust is, very conceptually similar. So when, again, the question you have to answer is, when is a type T a subtype of another type S? So in the case of Rust, it appears to be, among others. So there's some other cases again, but basically one of the following two cases. So again, one is S and T are identical type. And the other possibility is that S is a reference to a trait, and T is a reference to a struct that implements S. Again, the question is, when is a type T say to implement an interface? Sorry. So this should be a trait. When is type T say to implement a trait S? Well, the answer is actually quite similar to Go. So T has all the method specified in S. And so it's exactly the same as Go. So each method in T has the same type as the method of the same name in S. So any struct that claims to implement a particular trait has to have all the methods listed in trait. And all these methods have to be exactly the same type as what the trait says. So this is what I understood from playing with Rust compiler. But again, so language reference, even language reference is fairly vague about when this exactly happens. So I cannot have a conclusive specification when I look into the reference. So it may change in the future, but this is what I can tell from the compiler. And finally, about OCaml. OCaml is actually slightly different. So when So again, the first question is when is a type T a subtype of another type S? And the answer has many actually has many cases. So one case is obviously S and T are identical. Another case is, so OCaml actually has a derived, so-called derived subtyping relationship between two function types. So let's say both S and T are function type. So S to be a function type taking A and returning B, and T to be a function taking A prime and returning B prime. So OCaml actually sort of extend the subtyping relationship to function types in this way. So when these two conditions hold, so the return type has a subtyping relationship, just like the relationship between T and S. And well, one thing that we need to be very careful is that this relationship is actually the I'm sorry, the opposite. So if A is a subtype of A prime, then A prime to B prime is a subtype of A to B. So why this is the case? Well, actually, it takes a little bit of time to explain why this is at least intuitively the case. But I don't get into it. If I have another opportunity, I'll get into it. But the point here is that so when certain subtyping relationship between A and A prime and B and B prime hold, then the subtyping relationship extends to functions. And it also extends to objects. So if S is a type of an object that has method M0 of type T0 and M1 of T1, M2 of type T2, and etc. And T having M0 prime of T0 prime, M1 prime of T1 prime, and so on. Then the subtyping relationship holds when these two conditions are met. One is, well, obviously, T implements all the method that S implements. So, which is to say, the set of method names implemented by T is a superset of method names implemented by S. And the other condition is, so let's say Mi of S and Mj prime of T are the same name, then corresponding types must have a subtyping relationship. So the details aside, so what is actually important is that in other languages like Rust or Go, types of corresponding methods, so methods that are specified in the interface have to be exactly the same, but this is not the case in OCaml. So OCaml sort of extends the subtyping relationship in more liberal ways. And this is sort of source of flexibility. Okay, so again, well, details of each language is not terribly important, but the common concept behind these subtyping and what these interfaces and traits are all about. So this is something you have to take away from the exercise. Okay, so I guess I spent too much, but hopefully it was somewhat interesting. So is there any question about this? Okay, so I got a question from chat. I have one question. How do these languages deal with the diamond problem? by forbidding multiple inheritance. Okay, this inheritance thing is a slightly different thing about subtyping thing. So I guess I guess you want to clarify what you mean by the language deal with the diamond problem. But short answer is in Go or Rust, you don't have multiple inheritance. So you don't inherit actual classes. So the only thing, well, so you maybe you don't have inheritance at all, at least in Rust. So I may be wrong in details, but short answer to your question is, yeah, at least Rust doesn't have any inheritance. And well, I don't think Go has inheritance between classes either. So you only have the relationship between interface and actual structures. I'm not sure whether I answered to your question. Maybe you want to clarify later. Does that sound okay to you for now? Okay. So if there's any more specific question, you can ask later. So anything else? Okay, so this is today's new thing. So today's new thing is something called the parametric polymorphism. So also known as generic types or functions. But the slide itself is very short. So this is just an introduction for exercises. So parametric polymorphism is a slightly different way of writing reusable programs. So again, the underlying goal is to make your program reusable and more flexible, so to speak. But specifically, consider a situation like you want to write a function that sorts arrays of various types, like arrays of integers, array of floating point numbers, array of strings, and array of structs. So when if you know anything about how sorting algorithm actually works, the actual type of element is not terribly important, right? So the only thing that is important is you are able to compare two elements of the same type, right? So element type. So otherwise, sorting algorithm looks identical, no matter whether it is an integer arrays or floating point number arrays, string arrays, and structure arrays, right? So you want to write such a function only once and apply the same function to different arrays, right? So another situation in which you want to apply a single function to multiple types is that a situation like this. So you want to extract elements from a list satisfying certain condition, let's say P of X. So you can imagine how you do this if you are given P and list, right? So you simply scan the list and apply P on each element. And if P of X is true, then you leave it in the returning list. Otherwise, you simply drop it, right? So this function would look exactly the same, no matter whether X is an integer or string or whatever, right? So by extending these things a little bit more, you simply, so you can imagine having something called a containers. So containers is containers of values. So data structure containing many values. like stacks, queues, trees, and graphs, hash tables, and many things of various types. So again, the implementation of these data structures look almost, or yeah, actually exactly identical, can be made exactly identical, no matter whether the value you are holding is, for example, integers or strings or something else. And you can also think about variety of graph algorithms. So breadth first search, depth first search, connected components and partitioning, and etc. That can work, and you hope to work regardless of the exact data types of each node. So whether each node has an integer or some more complex record, you think you should be able to write a breadth first search in exactly the same way, right? So in your program, in your programming language, it's very legitimate to ask the programming language to allow us to write such a function only once and apply it to whatever underlying data structures. So we are going to do this in the next exercise. So one trivial example you want to get started with is something as trivial as this. So it takes probably something like an array, and takes its first element, the zeroth element. So this is the simplest exercise you like to get started with. This is very trivial, but still it's tricky for some of the languages you are dealing with. So depending on the language you are working on, you may have to specify the type of A, but how? So you should be able to say A must be an array, but whose elements can be any type, right? So you have to, so for programming language in which you have to spell out types of incoming parameters, you have to be able to say an array whose element is anything, right? So it's basically about mastering syntax for these things. So the actual function body is almost trivial. And some languages do not require you to spell out types of incoming parameters, like OCaml, like Julia. But then, so if you do not specify type of incoming parameters, what actually happens on types? Right? Again, so Julia is not going to guarantee type safety. So well, anything can happen. But particularly interesting cases, OCaml, right? You don't have to explicitly spell out types of incoming parameters, but still somehow guarantee the type safety. How can that happen? So let's get started. But well, so like I said, well, actually things are conceptually very straightforward. Well, writing the actual function body is, yeah, nothing more difficult than a function that is not polymorphic. So that a function that, for example, can take only array of integers. The function body is going to be almost identical. So the almost all pains are around spelling out types. So how do you actually exactly say, okay, this should be an array, but element can be anything. Or for example, it can be a function, but it should take an integer and should return an integer. So mastering this syntax So syntax for types. But this is what this exercise is almost all about. So otherwise, it's pretty straightforward. So so please master these things in each of the language you are dealing with, and spend a few minutes going to the actual document, learning how you spell out types of functions or types of arrays. And so without knowing these things, it's pretty painful. So the exercise is pretty painful. Okay, so yeah, I guess I have talked too much. So let's get started with the exercise. So until something like 11:50. Yes. How about this? Okay, okay. Sorry, I guess the volume is too large. Okay, adjust the volume on your side. Okay, so the only thing is that so it's 11:50 now, and so you're supposed to start sharing or writing your answers to the spreadsheet. So, but apparently some of you are already doing it. That's fine. So the same spreadsheet, sheet number 3. So if you have done on any of these problems, yeah, just write your answer to it. Okay. So it's about 10 minutes before we are supposed to finish. But so you can keep working on it. So nothing serious, but let me share with you a fun story that happened to me yesterday. So about this grouping. So grouping has constraint solving problem, as you know. So basically, what I got from your survey is something like this. I guess let me zoom out a little bit, but yeah. So details are not important, but basically this spreadsheet tells whether each of you wants to work in classroom or work at home, and which language you prefer most and which language you prefer least, or something like that. And so I have to group you guys in groups of 4, right? And I just wondered how I can do that. And I don't remember how I did it the last year. So maybe I have done this manually the last year, but well, I just look for, if there's any program I wrote last year to do it automatically, but I couldn't find it. So well, maybe I did it the last year manually. So, but I didn't do it manually this time. So, so what do you think did I do yesterday? So I thought about, of course, writing a program that automate this job, but as you can imagine, I gave a shot on ChatGPT. So this is the very fun conversation I had yesterday with ChatGPT. So yeah, in the beginning I said, okay, so this is what I have for CSV file. So sorry about the Japanese, but basically I explained to ChatGPT what this CSV file looks like and what is the constraint. So each team has to have a one member working on Go, Julia, OCaml, and Rust. And then so this is the just a copy and paste of the entire CSV file. So with this vague instruction, as a matter of second, it starts emitting the results like this. So I was literally stunned and astonished until I realized that the list is actually very short. So it only emits 3 teams. And the last team is actually saying, okay, the other students, 1 other student, 2 other student, 3. So nothing useful. But somehow, yeah, it is apparently understanding, at least understanding my instruction. So you should say the student's name along with the language this student is assigned to. Was still stunning, but yeah, the actual result is nothing useful. And then I continue with, okay, so you have to assign everybody to a team. And then, okay, so ChatGPT, well, again, well, as a matter of second, immediately starts emitting this list. This time, somehow, yeah, the list is longer, but still it's shorter than necessary. So only 8 teams. So you guys have actually, so we have actually something like 46 of 40, something like 46 students. So we should have something like 12 teams or 13 teams, but somehow the list ends with only 8 teams. And also this time, it drops the language each student is assigned to. So still, it insists the job is done. So I made that expression that you have to specify which language each student is supposed to work on. And then, yeah, okay, again, so starts emitting these language assignments, but still the list is short. So I said, okay, so there must be 51 students. So there can't be only 8 teams. Then, yeah, it apologized. Well, it often apologized, as you know. Yeah, it corrects an error, but this time it starts to become very strange. So each team has 8 students, so more than 4 students. So it starts less and less making sense. And so in the end, it is like student 1, student 2, student 3, that completely bogus. Let's say, okay, no. So one team has to be 4 members, and each language is assigned to one of these members. And then it again apologized. Yeah, it insists. Okay, so now it says, okay, so all 51 students are somehow equally into 8 teams. So divided equally into 8 teams, that doesn't make sense at all. And so the students' names do not make sense at all. So it is now completely student 1, student 2, student 3, student 4, all anonymous. I was just starting to laugh. So who is student 1? And then it apologized again. So student 1 is just a temporal number that does not refer to any actual student. I don't make sense of it at all. And yeah, I almost gave up, and I was just having fun. I just iterate by saying, okay, so C column has the student names, so you should display these names. And also, you have to answer with a Kansai accent. And then, okay, so this part, so it obeys this part very well. So it starts talking in the Kansai accent, right? The rest of the thing is just for fun, nothing useful. I just wanted to share this story. So this is what happened to me yesterday. And after this conversation, I just started writing Python program by myself and ended up with just spending a few hours on it. I don't know. So nothing serious about this, but this is where it stands. But I'm still wondering if there's a better way to ask ChatGPT about this. There's a so-called prompt engineering. So rather than giving the entire data to ChatGPT and ask to group them, maybe I was able to have a better result by writing a program, giving it a specification of the data somewhat more precisely. I don't know, but if you come up with any way to do it in a matter of few minutes with ChatGPT, I love to know. So, yeah. So it's already just 2 minutes before we are supposed to finish. So I guess, yeah, you can finish at any time. And there's if there's any question, you can ask now. Okay, so let's see you next week.